Okay, good evening, or morning. Welcome to
FamilyMath679.
FamilyMath679. So we're in the middle of watching Jacob Lurie's Breakthrough Prize public lecture, which is a really cool lecture. What's he talked about so far?
Like number systems.
So he's talked about like the counting numbers, the integers, the real numbers, and like the complex numbers.
Okay, what's he said about them?
So
We're about 5 minutes in.
he said that as you add each number system, you can solve more and more equations if you use like the number system above. So say if you use the counting numbers, you can solve more equations if you use the integers.
Okay. So give me an equation that you cannot solve using the counting numbers that you can solve with the integers. Here, let's leave this one up here because that's what he's talking about right now. So what's an equation you can solve with the counting numbers that you cannot solve with the counting numbers, but you can solve with the integers?
Say if we have like 2x is -4.
Ah,
You can't use negative numbers in the counting numbers. But
okay.
This would be x is -2.
Very
You
good.
don't have -2 in the counting numbers.
Okay, great. What would you like to add?
That's pretty much it.
Okay. Give me an example. Why don't you give me an example of an equation that you cannot solve with the real numbers?
So x squared equals -1.
Okay. X squared equals -1. What number system do you need for that?
You need the complex numbers.
Okay. And do you remember some of the ideas he said that all number systems have to satisfy?
So
There's
there's a bunch of rules for addition and multiplication that all number systems have to satisfy.
Okay. Yeah. Do you know what, like, say, one of those rules is?
I think there's like x plus minus x equals 0.
Okay. And that might have been one of them. Yeah. And do you know who formalized? Do you remember the name of the mathematician he mentioned who formalized these rules about what are called commutative rings?
I think it was
Something.
Emmy Noether. She was an incredibly important mathematician in the early 1900s. Okay, but so we paused the video when Jacob Lurie wrote down this equation and said it has no integer solutions, and I didn't want to give away the punchline. So I want to see if you guys can figure out why this equation, which looks pretty complicated, but we can tell relatively easily that this has no integer solutions. Do you have any ideas?
Well, you can't tell instantly what the solutions are.
That's true. It's very hard to see right away what the solutions to this are. And by the way, just to be 100% clear in case it was confusing, an integer solution would mean x is an integer and also y is an integer. Obviously, if we set x to be an integer, we'll be able to find some values for y, at least in the complex numbers anyway. But we need x and y to both be integers. And he's saying that can't be true, that x and y are both integers.
Well, if you just look at each side of the equation, so I pretend this doesn't exist.
Okay, that's good. That's a good strategy, by the way. We have something very complicated. Let's just look at a simple part of it. So I'll put the eraser gently over that side of the equation. All right.
So then we can just this x squared plus x plus 1 equals 0.
Okay.
And then we know how to solve this equation. We can just use the quadratic formula.
Right.
And then we can find that the roots of this equation aren't going to be integers.
Okay. Yeah, that's true. Right. Anything else can you say about that expression if x was an integer? Why don't you take a look? This expression, x squared plus x plus 1, if x is an integer.
well, if x is an integer, so we know it's going to be positive. It's going to be always positive.
Oh, why do you think that?
Well,
I mean, what if I put in -10, for example? What would happen?
so if you have -10 squared is still 100.
Uh-huh.
And you plus minus 10, that's 90. It's going to be 91.
Oh,
So
okay.
it's always, these equations are always going to be positive.
All right, maybe that's always going to be positive. Okay.
Alright. So then,
How else might, what are some things you could do to explore that equation a little bit, especially in the integers?
well, you could like try integer values. Or
Okay,
something.
yeah, why don't you try a few and you can write them down here. Like try what x are you trying? I mean, we already tried x equals minus 10, so you can write that down.
Alright, so I will try 7.
What was the value when we put in minus 10?
So it was 0.291.
Okay, great.
So let's see. Then, so it's try negative, it's 7, so 7. So we
Okay.
have 7 goes to 49, 7 is 56, plus 1, that's 57.
Okay.
So what if we had like maybe negative 3? So
All right.
9 minus 3 equals 6 plus 1 is 7.
Okay.
Hmm.
Any ideas?
No, not. Doesn't seem to be any consistency at first.
Okay.
There's not much pattern other than it always will be positive.
All right, maybe it looks like it's always positive. Why don't you kind of do the same thing with this side of the equation?
Well, this necessarily isn't positive all the
But
time.
it can be positive.
It can be positive, yeah. It isn't necessarily positive. That's a good observation. Just in case we're going a little long, let's break this into a second video. I'm just going to
Alright.
turn the camera on and off.